Okay, we have this 5381A Hewlett-Packard 80 megahertz frequency counter. This counter comes with a temperature compensated time base of 10 megahertz, and we are right now looking at the results of a calibration just performed on it. I had the unit apart. First had it warmed up overnight. It and my Rubium standard, which is up here. 10 megahertz Rubium unit in here, and it'd been on overnight, so it had a chance to come up to temperature, and we calibrated it to 10 megahertz, and right now I'm trying to figure out how close to the 10 megahertz I could be. Well, right now here's plus or minus a count, which would be 10 hertz. So let's put it into the 1 second time gate. I'm going to lose my 1 on the 10. It's going to be off to the left. But we're looking at 1 hertz here that we would be off in this gate. But that could be inaccurate too by a count. So let's go ahead and put it in a 10-second average. And we're going to wait 10 seconds here and see how we do. Okay, so we've got the unit calibrated to within 1 or 2 tenths of a hertz. I've seen this thing bobble between 1 and 2 the last couple rounds. Oh, she's holding. Looks like 2 tenths over. 2 tenths of a hertz over 10 million. So if you get the unit, you turn it on cold, she'll be a little on the low side, but as she warms up, she's going to warm right into the calibration. And right now, as you see, compared to the Rubium standard, we are extremely accurate within 2 tenths out of 10 million. So the calibration's good. Okay, we've got this 5381 hooked up to a PTS 500, and this digital generator is going to output signals from 1 megahertz to 500 megahertz. We're gonna try and test the limits of this this counter. Right now we've got 80 megahertz coming in, and we can see 80 megahertz on the display. The little bit off to the right is my generator is not going to be able to be as accurate as this counter is. So we see that we're 68 hertz off, 67, 68. But in any case, the idea is to show you that we have output in each range, each decade of range. We're going to do that. But right now we're going to test the upper limit. Right, it's rated at 80 megahertz. And we're going to go right now to 90. Not a problem at 90. We're going to do 100. Now at 100, our 1 is off the scale. We're off on the left. So imagine a 1, and then 0, 0, and then on across. Okay, 102 is easy. 103, 4, 5, 6, 5, 6. Okay, 106, it looks to me like it's starting to break. 107, yeah, I don't like that. Okay, so my conclusion from this is that this unit could be used easily to go up to 100 megahertz. Beyond 100, it is, well, 102 megahertz would work. 103, it starts to break down. So I would say if you went up to 99.9999, that you'd be in good shape. Let's go and test the other end, see how we're doing. Back to 80, 70, 60, 50, 40, 30, 20, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and we can turn our resolution up. So at 1 megahertz we're getting 999,999 something, and we could go to a 10-second average, but we don't care to. 1 megahertz is the limit of the PTS 500 for the low end, so we're going to switch now to a Hewlett-Packard 3320, and we're going to pick up at 1 megahertz. Okay, there we have 1 megahertz. Right, we're going to go 900 kilohertz, 800, 700, 600, 500, 400, 300, 200, 100, 90 kilohertz, 80, 70, 60, 50, 40, 30, 20, 10. Okay, let's try we're at 10 kilohertz again. We're going to go to 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright, we're at 1 kilohertz, 90, 900 hertz, 800, 700, 600, 500, 400, 300, 200, 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Alright, so we're gonna take a couple of more, and then we're gonna actually raise our resolution again. So let's go to 9. Now we're plus or minus a count and still accurate. So that's 9. Here's 8, 7, 6, 5. Alright, let's go ahead and raise up our resolution. We're on 10-second averages now, and we've also increased our sensitivity to the input because we know we're on the extreme range. Alright, 5, 4, 've have to wait for one more count here. We're waiting for a good 10-second average. That's 4. Let's do 2. We're looking for 2. We're going for another 10-second average here. There's 2. 1. One more average. There's 1. So we've gone all the way down to 1 hertz, and we went all the way up to about 103 megahertz. Not bad for an 80 megahertz counter. And we checked its calibration with the Rubium standard and found it to be remarkably accurate. And as always, I'll provide the counter with a good set of leads, brand new, and a good manual. So you'll have operation theory, maintenance, schematics and parts lists all included, and you'll have this very handy coaxial to gator clip lead set, and a beautifully restored HP5381A new paint job, beautiful front panel, and in totally good operating condition. So happy bidding, good luck to you, thanks for listening, and we'll see you again.